This historic oil can was made by the Pittsburgh Manufacturing Company. I will use it to show the principle of snap-through buckling and how ALGOR's AccuPack nonlinear software can readily analyze and predict this effect. Let's take a closer look at the oil can. Note, as I press on the bottom of the can, the movement seems linear at first. But as I press harder, there's a sudden snap, and a relatively large displacement occurs in a sudden jump. Then, when I release the pressure, it suddenly snaps back. To determine the thickness of the bottom, we purchased 2 identical oil cans and cut out the bottom of one. We measured the thickness at 10,000ths of an inch, or approximately 1/4 of a millimeter. We began the analysis by building a 2D finite element model using ALGOR SuperDraw. The critical part was modeling the spherical shape of the bottom of the can. Note that the edges are fixed to resemble the way the bottom is attached to the real can. A force of 1 pound was applied at the center of the computer model, ramping it up over time to simulate the real action of pressing the bottom of the oil can with your thumb. The applied force curve versus time looks like this. Here is a graph of the displacement of the center node versus time. The graph is automatically generated by the software during the run. Note the sudden plunge of displacement at the moment of snap-through. And here as the bottom snaps back. The sound or pitch of the snap-through agrees with the frequency shown on the plot. It occurs at 198 cycles per second or hertz and corresponds to the note G below middle C. The pitch of the snapback is somewhat higher with a frequency of 396 hertz or the note G above middle C. Let's take a look at the animation of the results. The animation shows the actual response of the model to the input load curve. The animation is, of course, in slow motion, with the actual response taking only 1 second. ALGOR AccuPack has the power and stability to handle snap-through buckling. It can make solving your problems a snap-through.